Okay, Edentech is a SME based in Paris, France, and we develop innovative solution for environmental application. And one of those solution is Scout, an AI-driven microplastic analyzer. Next slide, please. Okay. After World War II, the mass production of plastics began to increase quite a bit. And from the graph, you can clearly see that the production is projected to increase quite a lot in the coming years as well. With that comes the problem of microplastics. Most of you may already know or about the microplastics and how they are found everywhere. The image here, like the linear graph, kind of shows the major timeline associated with the microplastics and its first detection in various matrices. I'm sure nowadays you have heard or read in the news that how they are being detected in various human tissues, organs, and fluids as well. Next slide, please. And with the rise of this microplastic problem, the need to understand this microplastic is also increasing, and the whole process of microplastic analysis is quite complex, and it involves various stages, including the sampling, sampler processing, which can take up to several days because there is a need to separate the organic and inorganic particles via chemical digestion and density separation, followed by the sample filtering, drying, and the analysis itself, which can take up to 6 hours depending on which technology you are using to identify the spectra, as well as finally the reporting the whole findings. Next slide, please. So with our technology Scout, we are making microplastic analysis a lot more easier by simplifying the whole process. Sample pre-processing time is greatly reduced because the system can detect microplastics among other organic and inorganic particles. And this is also followed by automatic spectra acquisition, identification, automated customized reporting. Everything will be done within a span of 10 minutes. Next slide, please. So as I was saying, Scout can detect microplastics down to 20 microns, and it is completely automated. That is the data acquisition, processing, and everything will be performed within 10 minutes on a standard 47 millimeter filter. How is this important? Because nowadays you can clearly see that the tightening regulation concerning microplastic monitoring in drinking water and the implementation also of the extended producers responsibility regulations, because of Scout, it can be easily operated by anyone because of its easy to use design and making the whole process of microplastic analysis quite easy. It can be adopted by public authorities, industries, and academia as well. Next slide, please. Okay. Scout uses near-infrared spectroscopy for the analysis of microplastics. In general, plastics exhibit unique peaks and troughs around 1600 to 1750 nanometer. And also NIR has certain additional advantages compared to the conventional ones because it has higher penetration depth and it can penetrate deeper into the sample bulk. This gives certain advantages that we can analyze the samples when they're dirty as well as when they're wet in order to skip the drying process and cleaning process as well. And also it can acquire the spectra pretty quickly under 8 milliseconds per particle. Next slide, please. Now coming to the AI part, Scout has two machine learning algorithms that helps in sample analysis. The first one is microplastic vision, and it has three functions. The first one is the identification of the particles itself. As I was saying, it can detect the microplastics among other organic and inorganic particles. So once the filter is filtered and placed under the microscope, the algorithm is trained to identify the microplastics between other particles. The images pass through different layers and extract features concerning where the particle is, and also differentiate between particles like fragments, fibers, background, and also the background of the filter as well. Depending on what we are analyzing, sometimes the result can also be certain, which will also be highlighted when you get the result as well. Currently, the system has an accuracy of 94% to identify microplastics from the filter. Next slide, please. Yeah, next again. Okay. The next feature of the microplastic vision is its ability to provide metrological and morphological data for each of the detected microplastics, including the length, width, color, and shape of the particles that it has identified. The algorithm uses pixel segmentation to give like precise measurement of the particles that it has identified. And lastly, the final feature of the algorithm is to identify the quickest way between the particles. As you can see in the GIF that is going on the slide, it identifies the quickest way between each particles. The idea behind this is the spectroscope will move in this quickest possible way to acquire the spectra as quick as possible, further increasing the speed of the analysis. Next slide, please. The next machine learning algorithm we have is called Plastic ResNet. It analyzes the acquired spectra and identifies the microplastics. Currently, the system is capable of identifying up to 20 different families of plastics at an accuracy of 99.3% and 9%. Both of these algorithms have been validated in lab using real marine microplastic samples that were obtained by IFREMER, which is an oceanographic institute in France. And also we are analyzing the real samples that are obtained from Danube River from another project called Sundance. Next slide, please. Finally, coming to the performance and user interface of the system, as I was mentioning, is really quick. It can analyze up to like 25,000 samples, particle samples within a matter of 322 seconds at approximately like 8 milliseconds per particles. And sometimes, as I was saying, if the system doesn't really identify the particle, it goes back and reanalyzes so as to increase its efficiency as well. And currently we have a limitation up to 20 microns, but we aim to go down to 5 micron in our next update. The main advantage of the system is its simplicity, which is the one-click analysis. So it can be used by literally anyone, and it is not just reserved for the skilled person. So it can be adopted by public authorities, industrial personnel, and everyone. And everything is done with just one click, which executes the complete imaging, spectral acquisition, particle dissection, and also the final reporting as well with minimal intervention. Next slide, please. Finally comes the reporting part, which was quite similar to what Kostas was explaining as well. We have the final reporting, which will be done by the AI as well. Everything, including the image of the microplastic that was detected, the predicted polymer, its prediction confidence, because you need to know, like, if at all sometimes the particle was not 100, like, if the confidence level is less than 50%, you can maybe recheck or something like that. So, and also you will get the meteorological information concerning particle that was identified. Everything will be in the report, and this report can also be customized to based on your requirements as well. So for public authorities or for industries, for monitoring, you can customize the report how you see fit as well. Next slide, please. I think that's the end of my presentation.